So, hello and welcome to this video, Autodesk Fusion 360. This video is all about the base version of Autodesk Fusion 360. I'm going to talk about the main features of the software, and additionally I'll be going more into detail on why this software is interesting for plastic part designers. And so there's the product design extension, which I'm going to be talking about, and all about its main features. And also, finally, I'll be talking about the simulation extension with a main focus on the injection molding simulation. So this is going to be very interesting. And yeah, I'm going to talk about this more in detail in the software. And what's also included in this video is there's time steps, so you can also just jump to the simulation extension if you're interested in that. And this makes it hopefully a little bit more enjoying to watch, and you don't have to listen to everything that I'm saying. So first of all, I want to go a little bit more into detail on what Fusion 360 actually is. So it is mainly a software which aims on enabling to create perfect plastic and metal parts, and also parts from other materials, and to improve them as much as you can, with a focus on the design phase, but also on the modeling phase, and then later on also on the manufacturing phase. So software wants you to help you on each step, from designing to going to the correct manufacturing process and to the perfect finish of your part. So it's an integration of many options, starting with computer-aided design, CAD, and also CAM, which is computer-aided manufacturing, for example, drilling and cutting. You also have the option to do electronic setups. So motherboards, for example, you can design easily in the software. You have the option of generative design, which is a very cool and nice way that also includes topology optimization. And then you have documentation and collaboration. So documenting, of course, drawings and of models and dimensions. And collaboration I will show later, but yeah, you can also work in teams, work with other people, share your designs, and so on. And from our point of view, at least, the most important aspect is simulation, which is quite new, and also has the Fusion injection molding included now. So a quick and easy way to do injection molding simulations in the software. To give a little bit of an insight, so what Fusion 360, the base model actually is. So you first require Fusion 360 basic software, which is available as a rental license, and it usually costs around 500 euros per year, depending on whether there are specials or not at the moment. And inside that, you have all the standard features and possibilities of Fusion 360 included. And it is a single user license, so only one person can have access to it, and it's personalized. So it's usual trend, as we can see in many other software, for example, Adobe, or even your Netflix account, which is personalized and single user based usually. So to give you a nice overview, or brief overview of the software, I just collected some of the most important features of Fusion 360. So the first and most important feature possibly for product design is the sketching, because without sketches you can't really get from an initial design to a complete model. So what you can do in Fusion is you can create lines, circles, rectangles, two-point rectangles, two-point circles, splines, and many more features to create first drafts, first sketches, from which you then can go into the modeling. And the modeling, you can see, is also quite advanced. So you can do all kinds of extrusion or bulge operations. You can create holes and radii, and many more things to improve your designs and the designs of your parts. So this is just a very brief overview of all the options. So this is basically what Inventor or AutoCAD can also enable you for part designs, but sketching and CAD modeling, of course, in one. And the next one that you can also do inside the software is you can create advanced meshes. So you have a lot of options to create meshes. One use case would be to create, for example, STL files for 3D printing purposes. But you can also create meshes for simulations, so for all kinds of simulations. You can export the mesh into other software, or you can also use it for the options available in Fusion 360. Another one is high-end surfaces. So you can also create very nice surface models inside Fusion 360. This also works with T-splines, and you have very high-quality optics that you can create inside Fusion 360. So one example, as you can see here, is the shampoo bottle. From an initial sketch on paper, you can get to a model pretty quickly. And what you can also do is you can create renderings inside the software, which are also cloud-based. So you can do that for inside the Fusion 360 base model. You can create very nice renderings of your products. And additionally, I want to go a little bit more into detail. We also have parametric design with all of the steps in the design process. So you have a timeline with all changes that you've ever made to your model. And those changes can be changed afterwards also. So you can have a very quick and easy, you can quickly and easily adjust some of the options you took earlier or you made earlier, and adjust your model accordingly. Or you can also create 2 or 3 different versions of your parts, and later on do 2 or 3 simulations, and you can find out what, for example, a wall thickness change in this or that area has an impact onto your simulation quality or your processing quality later on. And of course, you can also retrieve earlier decisions. So for example, wall thickness change from 3 to 2 millimeters in one certain area or another. That's a very nice way and very easy way of modeling. And the most important point regarding cloud-based software or cloud-based platforms is the collaboration option. So as you can see, we have our own MF software company group. And inside that group, you can create folders or data packs or whole projects. And then you can just invite people which you want to which you want to join one or the other group, and then you can collaborate and you can work together on the project. For example, you can have a designer which is working on the project, and on the other side you also have the simulation engineer, or even the one that's working on the machine later on, and that person can also have access to all the results that you've created. You can also make global changes, and you can make them especially visible to everyone in the team. So you make sure you always work on the same most current project and most current version of your parts and your designs. Yeah, so that's a brief overview of the main features of Fusion 360. So the next topic that I want to talk about is the Fusion 360 product design extension. So this is one of the additional extensions that you can get for Fusion 360. So what I've been talking about was only the main software, like the Fusion 360 base software. And additionally, now you have, just like every good platform, basically, you can just pick stuff and attach it to the base model. And yeah, this one is the first one because it's very interesting from our point of view as plastic part designers. We have the product design extension. It's around 800 euros per year. So this also depends on whether there are specials running or not. And because I want this video to last maybe more than 1 year, I just say it's around a certain number, because you never know how much it's gonna cost next year or in 10 years. And this includes very interesting features from a plastic part designer's point of view, starting with the plastic part rules, which I will show you soon. Embosses, snap fits, you have geometric patterns, and you have design advice. And to give you a little bit better overview of what this means, go into the next slide, and it's starting with the plastic part rules. So what does that mean? Basically, you have the option to create rules for certain materials and also for certain parts. And as you can see here on the right, you basically just select the material you like. You can give it a name. In this case, it's very broad. So it's called, for example, polypropylene. And as we all know, or as most of you know, there's many different types of polypropylenes. So you can just create polypropylene, basic polypropylene from this or that material supplier. You can also create another polypropylene with, for example, 40% glass fibers included. And then you can give the material a couple of rules. For example, the thickness range, what the usual wall thickness should be, what the thickness variation should be, what a maximum draft angle should look like, or a minimum draft angle, and also radii and other aspects. So this rule you can then apply to a certain part inside your assembly, and then the software will always keep those rules in mind, and it will remind you when you are not really sticking to the rules, and it will just keep some certain design basic rules inside the designer's mind, and so that it's easier for him to or her to stick to those rules. So this is a very nice tiny feature inside the product design extension. From then on, it's going a little bit more into the more practical part. We have embossings, for example. This is a very nice and easy way to create embossings. You have a whole database basically of options to select from. So as you can see here on the right, there's different types of screws that you can choose. You can change the diameter, you can change the thickness, you can change the chamfers or fillets of the surroundings, and also the angles. So there's many options to create embossings with just simple clicks. So you don't really have to design them yourself. You just select the correct aspects and details, and then it will immediately be placed inside your model on exactly the spot that you've picked. And another option which is a little bit similar is the snap fit option. So snap fits are also very the design of a snap fit is very depending on the plastic type itself, and also on the loads that will be put onto a snap fit later on. So you have a couple of nice options to select the correct snap fit for the correct plastic that you're using, or the correct material that you're using. And you can just adjust the values the way you want it to, and then it will automatically be created. And what's also a nice thing is that in the material database Embase, you have also very important and interesting details about snap fit designs included. So you can just take those details for the correct plastic material and then just put it into Fusion, and you will have a snap fit created immediately. So this is a very, very nice feature. What we also have inside the product design extension is geometric patterns. So you can just create geometric patterns, for example, those holes here, or the distribution of those holes in a very quick and easy way. You can make the holes increase over the distance or decrease, or you can have a random or a more uniform distribution of your holes. You can also create rectangles or other types of objects. So there's many options here to just quickly create nice geometric patterns inside the software. And now to the most interesting one, or to the most important feature of the product design extension from the plastic part designer's view. This is something that some of our customers might already know from the Moldflow advisor. This is called the design advice. So what you basically have to do is you have to select the part, and you have to select the pull direction of where your mold's gonna come together. And then the software will analyze the part, and it will calculate the thicknesses, undercuts, draft angles, and knife edges of your part. So what does this look like? I have a tiny example. First of all, it's going to give you, after the analysis, combination of all of the hints and an overview of the hints that it has collected. And then you can already see how many issues you have. So in this case, there's many issues, but it's also not a very advanced design. It was just an example. And if we have a look at the thickness distribution, for example, some of you working with Moldflow will already know this result. So in this case, you just see how thick which region of your part is. And you can very quickly see where you have too thin wall thicknesses, maybe mass accumulation somewhere. And the software will tell you here which area, for which area you might have another look at, and you might have some variations to that and some adjustments. So there's always a list of recommendations for each of the features. Yeah, the next one is undercuts. So as you can see with our snap fit here, there's obviously an undercut there. So you will need to have a slider inside your tool. And yeah, this is being shown as the red area here. So we know there will be a slider below the snap fit. And what this can be used for really easily, like especially in the early beginnings, you can already assume or estimate the design costs of your tool later on. So you will have a very quick overview of all your undercuts and of the complexity of your tool later on. Next one are draft angles. Of course, for ejection purposes, you will need a draft angle on your on all of the sides that will be ejected or are inside the ejection direction or the pull direction. So as you can see, I designed this part very nicely without any draft angles. So this should obviously be adjusted. And also here, the plastic part rules come into mind, because the draft angle is also something that can be adjusted to the plastic that you're using, a plastic type, material type. All right, so this was an overview of the plastic of the part design extension, and now we can go into the next extension, which is called the simulation extension. This is probably the most interesting extension. It costs around 2,000 euros per year, and it includes a variety of different simulation types, and one of them is the injection molding simulation. So for this, it's possible to run simulations locally with some of the simulation types, or you can also run simulations on the cloud for tokens. So you have to use Autodesk tokens, and then you can just run on the servers of Autodesk. So let's go a little bit more into detail on this one. I will switch into the software itself for this extension. All right, so now inside Fusion 360, this is how the software looks like, and we are already inside the simulation extension right here. I just wanted to step back into the design feature just for 1 second, just to show you what the part looks like. So this is basically an assembly. It's the housing of an antenna or router, and what we are gonna pick is just the lower part, so the lower bottom part of our assembly, and we just jump into the simulation option here inside the software. And now the injection molding simulation has already been picked, and we can already have a look at the results of our simulation. But before we do that, I'm gonna go a little bit more into detail just to show you what you can set up and what the software is all about. So the first thing that we can see is there's a cone, which is the injection location that I've just picked. So this can be picked up here, injection location. You can also pick multiple injection locations, but you cannot create any runner design or runner diameters yet. So far it's just the cone, and you can just place it on your part. And what you can additionally select is the green areas that you can see around here. Those are aesthetic faces. So those are meant to be areas that the software should have a closer look on, just to make sure that the quality of those faces is perfect in the end. So that's what I did. I selected the aesthetic faces and the injection location. And from then on, we also have the option to select our process settings. So right here we have the option to select our injection time, which can also be calculated automatically by the software, but we can also specify it some little bit closer. Yeah, so 1 or 2, 1.25 seconds or whatever we wish. Usually the rule is around 1 second per 100 millimeters. And further below, we have the option to select our melt temperature and also our mold surface temperatures. This is in Kelvin right now, but we can also switch to metric units. We can also change the whole language of the software to German or to English or to some other languages. And further below, we have the option to compensate for shrinkage. So also that's possible. And we have a shrinkage allowance, which has automatically been calculated for this material itself. And also these values come from the material database, which we will have a look at in a minute. So this is what we can set up in the process. There's not a lot of options. There's no packing pressure option available so far. So this is just the main basics. It's a very quick and easy way to set up the simulation. This, however, does not mean that there's not going to be any packing pressure calculated, but there will be a default packing pressure profile, which we can also see later on. So another thing that we have to select is our material. So if we click on the materials database, this is what's opening. So we have a whole database of materials with more than 12,000 materials included. So this is basically the Moldflow database, just completely integrated into Fusion 360. You will not find as many values and as many details inside those material data sheets as in Moldflow, but the materials are exactly the same. Most of them are of high quality. You can also check the quality indicators inside Fusion 360 and also some of the values. So this is a very nice feature. We really have many materials included in here. We have a nice way of searching for all of the details of our materials. So also alternative materials are easy to find inside the software. And yeah, then we can just select them. And from then on, we can already do our calculations. And this is something that I've already done in this case. So if we look at the job status, I performed 5 calculations. Very interesting. I did them all at the same time also because everything's running on the cloud. It's only available on the cloud for the injection molding version to this date. And they are all completed. And I can have a look at all of the results already. So I can just click on results and the software is loading the results of one of my studies. So let's just have a quick wait. And now we can see some of the details popping up. So on the left, we can already see there's 3 different areas. One is for the fill results. You can see that our part is going to fill completely, and we can see the fill confidence result, which shows 100% easy to fill in all of the areas of our part. The second that we can have a look at is the visual defects. So this will show us where exactly are sink marks and also where can we find some weld lines forming. So many weld lines behind all those holes. And due to those areas also being static phases, we have some hints that are being given to us about those phases. So we will have some visual defects because of sink marks and also weld lines. And then we have our third one, which also shows a warning. And this says that our warpage might be too much. We have a little bit too much warpage. You can see the tolerance is set to 0.25 and the maximum warpage 0.63 millimeters. So it's too much for the settings that we have right now. And you can also, of course, set the tolerance to whatever you wish or to whatever your criteria are. And then you can just change the geometry, have another run, compare the runs with each other. So this is just the brief overview, and you get some information and some ideas on what next steps you could also be doing. For example, you can adjust the injection location area or the wall thicknesses or the process settings and so on. But what we also have is we have the results as we know them from Moldflow. So the first example right here is the fill and pack and also the warp area, but the fill and pack starting with the filling animation. So as most of you will already know, this is not really different from any other software. We just have the filling process. You can see where weld lines are forming. We can see that the simulation runs in 3D and true 3D elements. So this is also very nice. You can see that the part is filling very nicely in a quite uniform way. Yeah, then we also have the fill confidence as we've seen earlier. So the part is 100% easy to fill. The next result that we can see is the quality prediction. this shows some minor issues. For example, these bosses show some larger volumetric shrinkage, which we can see later on, because the wall thickness is just a lot higher. And then we can also see around our injection location, this will obviously have an effect on our quality and aesthetics of the part, and maybe also some shear, which is probably a little bit higher in this area. Then next we have the injection pressure, which is around 300 bars in this case, and we have a little bit lower pressure because this is the last filled area, so we have a little bit of an asymmetric filling behavior in this part. The next one that we can have a look at are the flow front temperatures. So we can see is our injection time. Did we pick a correct injection time, or are we filling too slowly, too quickly? What could be improved in this case? So we have a slight decrease over our flow distance in this example. Then we have average temperatures, so we can see at the end of fill that thinner areas at these bosses are already cooling down quite quickly. So we can see on the scale on the right, and most of the rest of the part is quite uniformly in temperature. Then we can also have a look at our cycle time. So the time to reach ejection temperature shows us that the thicker areas, especially in those bosses, they have quite a long time to reach ejection temperature of more than 30 seconds. And we can also see some differences in our main wall thickness area. And as we can see in this example, that the area where we are injecting is a little bit thinner. So this thinner area leads to not really a perfect distribution of packing pressure, and this leads to a higher shrinkage in these outer areas, and also to a longer cycle time. So the cycle time we can see here already, and the shrinkage we can see in the next result. So in and around our injection location area, it's very low. And in the little bit thicker areas around our injection location, it is a lot higher. So to reduce this, we would probably need to increase the wall thickness of our injection location area. And with a higher packing pressure, this should not be, I'm pretty sure this will not be solved, this issue. But it's just an example. Then we have also solidified plastic at the end of fill, so we can see which areas are already frozen at the end of fill. You can see some corners, some areas around the bosses are not solidified yet. And at ejection, we can see this is a lot. We have most areas are already cooled down at ejection, but the thicker areas in the bosses, they require some more time to cool down. What else do we have? We have air traps. So these are being shown especially in areas where we need some vents in and around those domes, because the air has to leave somewhere. You can see a couple of them. And also in our parting plane, we can see that there is air which is being trapped inside the part, or will leave because of our parting plane being in this area. The weld lines, as we saw them earlier, we can see behind all of the holes that we have on our part, and also behind those bosses, because the melt is just flowing around them and then reconnecting behind the bosses. Filled from ejection location. This is injection location. This is not very interesting because we only have one injection location. If we had two, we would see, or three, we would see a little bit more like this image in the preview area. And then we have sync marks. This result we can also have a look at. Needs a little bit time to load. We can see here's a tiny little bit, and as we increase this some more, we can see that there will probably be some sync marks in and around the high volumetric shrinkage areas inside our bosses. So quite some results, and also many very useful results in this example. And from then on, we can switch and look at our warpage once more, and we can have a look at what our warpage result is looking like. So we can see, if we scroll to the corners, that the part is decreasing in size, of course, because of the shrinkage behavior of our part. And we can also see from the colors that the part is warping more on the outside and in the other direction on the inside. So we will have some sort of buckling behavior on this part. So this is not very surprising due to the geometry that we are seeing. But yeah, it's very interesting that we can have a result like this inside Fusion 360 already. So this is very nice, and we are pretty certain that this is going to be improved, and this will be extended by many, many more features in the future. So right now scaling is not available yet, but pretty sure it will be available soon. And then we have one last result, which we already had a look at, which is the warpage tolerance. And yeah, this shows, or this gives us the opportunity to just select a tolerance which we have on our part, and then have a look at which areas are exceeding those warpage values and which aren't. So I hope this gave you a nice overview about most of the features that are available now inside the injection molding feature of Fusion 360, of the simulation extension. Just to give you a quick overview, there is also some more options available. Of course, I just showed the injection molding simulation feature to you, but there's also a lot more. We have many mechanical simulations, and we also have some thermal simulations, also in combination with mechanical. And yeah, there's even event simulation inside the software already. So there's a lot to discover, and I think a lot of very useful features. So as an overview, why should there be the use of the simulation extension? Yeah, I think it is a very quick and easy way of simulating. It takes those simulation took me around 10 to 15 minutes. It was very quickly. And it's also very nice and quick to handle the post and pre-processor of Fusion 360, because it's on such a modern platform. Everything's working quickly and easily, and it's very nice to work with. And yeah, there's just a very easy way of changing geometries inside the software and then just test them immediately. So you can just change the wall thickness here or there, put in some holes, or change the size of the ribs, and then just switch over to the simulation feature and try it out and find out whether the design is suitable or not. So this, I'm pretty sure this will reduce the designs of many companies, and this will reduce the costs of prototyping immediately. And to the final question, who does the software relate to? I think this video should have made it quite obvious that this is very useful for part designers, especially. for basically all the mentioned reasons in this video. So the part design extension that I've shown to you, all of the main features of Fusion 360, which are super useful for the creation of parts of any kind, metal as well as wood or plastic. And this could also relate to users of different simulation software, especially the simpler ones, and also advisor customers, so Moldflow advisor users, which especially the ones that are using Moldflow Advisor Premium, because they do not have access to warpage calculation, which is included inside the simulation extension. So yeah, many nice reasons to work with this software, and I'm pretty excited about the experience that you, the viewers, are going to make, hopefully. And yeah, you can write into the comment section if you have any questions, or you can also contact me directly for any questions or any further presentation of the product. So I will be very glad to be talking about this product more and more, because I really like it, and I think it's going to be a very nice platform in the future. So I would like to thank you very much for listening to this video, and I also want to encourage you to check out our other webinars and videos on YouTube. There's a lot of very special topics that we're talking about. There will be there will be more in the future. So thanks a lot, and yeah, just contact me for any more information about Moldflow, injection molding simulation, or any other plastic part designing related topics, and I will be glad to have a talk and to discuss some solutions that we may be able to offer you. So thank you very much, and see you in the next video.